All right, let's dive in. Today, we're cracking open a technical manual for SQL, the structured query language. Now, I know that sounds kind of dry, but trust me, this is basically the secret instruction booklet for one of the most powerful tools in the world today, and we're going to break it all down. Just think about it for a second. Every single time you click something, buy something, or do anything online, you're creating data. Companies have these massive tables with millions, sometimes even billions of rows. How on earth do you even begin to ask a question of that much information? It's a huge, huge challenge. Well, the answer is you've got to learn to speak its language. SQL is that language. And this manual we're digging into, this is our guide. It's what lets us talk directly to our data. Okay, so before we can jump in and start solving all these crazy problems, we got to start with the basics, right? We need to learn the grammar. What are the actual words and punctuation marks that make up SQL? This is such a great way to think about it. You're not just, typing code into a black box. You're actually formulating a question. You're having a real dialogue with a database that holds a mind-boggling amount of information, and if you ask it the right way, it's going to give you a perfectly precise answer. So this table here, it basically lays out the core building blocks. Think of them as the verbs and nouns of SQL. You've got your arithmetic operators for doing math, like say giving everyone a 5% raise. Then there's the concatenation operator, those two vertical bars that just lets you stick text together. Comparison operators are all about testing things. Is this number bigger than that one? And finally, you have set operators like union and intersect, which let you combine the answers from different questions. These are the absolute fundamentals. Okay, so we've got the basic language down, but here's the thing. The first big hurdle everyone, and I mean everyone, hits is that data in the real world is never perfect. It's messy, it's inconsistent. So let's see how our guide helps us clean up the mess. And yeah, this is what that mess usually looks like. You're pulling in data from all over the place, people are typing things in a little differently, and you end up with, well, a bit of a disaster. So where do you even start? Here is a perfect textbook example. We've got all these extra spaces at the beginning and the end. The last name is first, followed by a comma. Now, a person can look at that and know exactly what it means. But to a computer, nope. That is a totally different string of text than Hernando Villegas. But the cool thing is, SQL gives us these really precise tools to fix this. First up, as we see here, we use a command called trim to just snip off all those extra useless spaces. Next, we can use other functions like substring to intelligently grab the text before the comma and the text after it. And finally, we use that concatenation operator we just talked about to stitch them back together, but this time in the right order. And boom, just like that, from a messy, kind of useless piece of data to something clean, perfect, and standardized. This cleanup work is a massive part of dealing with data, and SQL gives you the tools to actually manage it. Okay, but what about the really tricky stuff, like typos or different spellings of the same name? Well, the manual introduces this super cool, almost magical function for this called SoundX. It's actually a system that was developed way back in the 1880s for the US Census, and it codes names based on how they sound phonetically. Just look at how powerful this is. Even though John, Joan, and Joanne are all spelled differently, SQL is smart enough to know they sound the same, and it gives them the exact same SoundX code, J500. Bob, on the other hand, sounds totally different and gets a different code. This is such a game changer for finding data you'd completely miss because of a simple typo. All right, let's switch gears a bit and talk about something a little more philosophical, but absolutely critical. What happens when data isn't just messy, but it's completely missing? How does a database deal with nothing? It's a weird question, but the answer is so important. And you have to understand this distinction right here. 0 is a number. It's a fact. It's a known quantity. If I have $0 in my account, that's a piece of information. Null, on the other hand, is basically a shrug. It means I don't know, or this value is missing. If my account balance is null, we have no idea what's in there. Could be 0, could be $1 billion. Getting this difference is key to not making huge mistakes. And this is where people get into trouble. Because, as you probably remember from math class, you just can't divide a number by 0. It's undefined. In programming, it'll just crash your whole calculation. So how does SQL protect us from this classic trap? So our trusty manual shows us this super clever solution, a function called nullify 0. It is such a simple but brilliant little safeguard Basically, before you do your division, you wrap the number you're dividing by in this function. And if that number happens to be a 0, the function just automatically swaps it out for a null. And here's exactly how it plays out. Look at this example here. Smith has a handicap of 5. Nullify 0 looks at it, sees it's not 0, and leaves it alone. No problem. But then we get to Newman, whose handicap is 0. The function steps in, sees that 0, and converts it to null, which is what that question mark represents. Now your calculation won't crash. It'll just result in null, safely telling you the answer is unknown. Okay, so we've wrangled our messy data, we've handled the nothing problem. Now for the really fun part, the payoff. This is where we use SQL to take all those millions of tiny data points and finally see the big picture. This is where the real insights are hiding. So here's a little peek at some raw sales data. Each line is just one transaction. Now, here's the thing. Imagine this table doesn't have 6 rows. Imagine it has 60 million rows. You can't just scroll through that looking for an answer. You have to summarize. And the way we do that is with something called aggregate functions. Now, it sounds fancy, but the idea is incredibly simple. They are special commands that take a whole mess of rows and boil them down to one single useful number. They help us go from a sea of data to a real answer. For example, we could ask a simple question, hey, how many sales transactions are in here? We use the count function, and for our little table, bang, the answer is 6. It's simple, sure, but it's our very first piece of summary information. Okay, but that's just a count. What about a more valuable question, like, what's the grand total of all sales? For that, we use the sum function on that sales column. And instantly, SQL scans every single one of those rows and gives us one powerful number, $290,000. And that right there is the whole magic trick. It doesn't matter if it's 6 rows or 60 million. SQL and these aggregate functions can take all of that complexity and just distill it down into a single, powerful, understandable answer. Average, sum, count, min, max. These are the tools you use to find the signal in all the noise. So you see, the language itself, the basic words and grammar, they're actually pretty simple. You've got tools to clean things up, tools to do math, and tools to summarize. But when you put them all together, the answers you can find are just incredible. The real power isn't in the language itself, it's in the questions you decide to ask. So the only thing left to figure out is, what will you ask?